Today I want to talk about several things, and I'll be brief, or I'll try to be quick, and I can handle a bunch of questions from you. I'd like to talk about several things: how the computer industry is changing. Second, why is generative AI so transformative? Third, how are the industries and countries racing to own their AI? Why are they doing that? How are they doing that? And why is this extraordinary? This is an extraordinary time and opportunity for Singapore. The global computer industry is going through two simultaneous transitions. This hasn't happened in a very long time. And NVIDIA is at the center of both of these. One of them is called accelerated computing, and the other is called generative AI. The first, general purpose computing, or using brute force, using one general purpose processor to do everything and anything, is no longer cost or energy efficient. Data centers must accelerate every workload possible today and shift to accelerated computing whenever they can, in order to achieve an order of magnitude better performance, energy efficiency, and cost. The second is that accelerated computing enabled generative AI, a new way of doing software, driving a platform shift in software and enabling never before possible applications. Many of you know that very well. Together, accelerated computing and generative AI are driving a broad-based platform shift. This isn't something that doesn't happen regularly, and it hasn't happened in my entire career. The IBM System 360 was invented the year after, or was announced the year after I was born, 1964. And the System 360 describes a computer that uses a central processing unit. It is divided into memory hierarchies, caches, system memory, and storage, the invention of disk drives. It describes an architecture of computing with I/O subsystems, and very importantly, it describes a family of computers with software compatibility across the entire family and across generations. I have just used words to describe today's computers. The computer hasn't changed in 60 years, until now. The way software is written hasn't changed in 60 years, until now. And so it stands to reason we have to pay attention for what is happening, why it's happening, and the opportunities ahead as it happens. NVIDIA pioneered accelerated computing. It took us almost 30 years to do so by inventing a new programming model called CUDA and adding a processor. We just happened to call it a GPU. A lot of people thought I should call it a whole bunch of other things, but I decided to keep it a GPU, and to offload and accelerate workloads from the CPU. Workloads that the CPU was not efficient at doing. It's a sensible thing that all of us do in life, and is a sensible thing for a computer to do. That we should use the right instrument, the right tools for the right job. And by doing so, we improved performance while reducing the cost and energy by orders of magnitude. And after nearly 25 years, NVIDIA accelerated computing has achieved broad success. It is now trusted by ecosystems of developers, system makers, cloud service providers, technology makers, and end users. What I just described is a new computer architecture based on CUDA, a new computing approach called accelerated computing, and it is now literally everywhere. It's in every cloud, it's every system maker, it's in every single industry. Something like this hasn't happened in 60 years. And an extraordinary circumstance. And a computer that, if you program it properly, can deliver 10, 100, and over the course of the last 10 years, 1 million times speed up. In what instrument have you ever experienced where in just 10 years, its performance improved by 1 million times. If a Cuisinart were to do this, dinner will be fixed before you started it. This is an extraordinary circumstance. And that's one of the reasons why NVIDIA has found itself at the center of so many technology transformations, so many industrial revolutions. NVIDIA's accelerated computing enabled the advancement and expansion of deep learning and large language models, which led to generative AI, the start of a new computing era and what many are framing the fourth industrial revolution. That is probably an understatement when it's all said and done. The automated production of intelligence, the most valuable asset we know. To be able to produce it at scale and automatically is unimaginable. For a lot of people, it's hard to even imagine what it means to produce intelligence. How do you manufacture intelligence and what does it look like? In the third industrial revolution, something amazing was discovered. Water goes into a building, fire was applied, and something invisible came out. And that invisible thing was transmitted hundreds of miles away. And by turning it on, you have light, you have heat. We manufactured energy, we manufactured electricity. It was invisible, it was incredibly valuable, it changed everything. Today, we have a building, we apply energy to it, there's a special instrument inside called a GPU. You input raw material. That raw material is electrons in the form of data. And what comes out is more electrons in the form of tokens. And these tokens are valuable. These tokens are called artificial intelligence. I've just described in a GPU today. It is extremely large, looks like a factory, and in fact, this is the new industry. A brand new industry has been created. It is not a data center of the past. It is not a data center, in fact, at all. It is an AI factory. And we now harness, refine raw material called data, and transform it into the most valuable asset the world's ever known, intelligence. And we do it in high production. We do it at scale. And we're at the beginning of that revolution, the beginning of that journey. Generative AI, as you know, has figured out how to recognize patterns in relationships. And from the numbers that you provide, the numbers could represent text, it could represent images, it could represent motion, fluids, temperature, sound, proteins, chemicals, amino acids, genes. It could represent anything you like it to represent, and it could discover patterns in relationship among them. And by discovering the patterns in relationships, it understood its meaning. To be able to understand the meaning of words is not so, it's very magical in the sense that a computer could do it. All of us could do it. That's what makes us intelligent. But for us to be able to understand the meanings of amino acids, to understand the meaning of genes, and to be able to interpret and translate from English to English, captioning or summarizing, from image to text, from video to steering action, self-driving cars. All of these translations from images, from information to information is now possible as a result of generative AI. And the implications to industry is extraordinary. Now this field is moving very quickly, and you're, of course, watching it very closely. Large language models and generative AI have advanced enormously in the last 12 months. since ChatGPT. Now, of course, people are still talking about ChatGPT, but inside the industry, we're talking about a whole bunch of other things. And the progress is enormous. And you see many of it. Let me highlight just a few. You know that foundation models now are multimodal, so it can understand text and images at the same time, achieve very high skills in language and basic math, and some basic reasoning. Of course, multi-step reasoning has long ways to go. System 2 thinking, slow thinking, fast thinking, AI is very good at. Slow thinking, not so much. There's enormous opportunities for breakthroughs there. And so what has happened to the computer industry? When you take a step back, you just realize what happened. Software is different. The way you write it is different, and what you can write with it is different, but the industry is different. There's a whole new industry that sits on top of the old software industry. The software industry of the past created tools that humans used. Excel, PowerPoint, Photoshop. These are digital tools that people used. Now there's a whole new layer above that. Co-pilots, assistants, whatever you decide to call it, AIs. These AIs are going to be users of those tools. And instead of licensing software tools, you're going to be hiring, recruiting AI workforce. This layer sits on top of the software industry of the past. The software industry of the past will still continue to be there. $1 trillion of software industry is not going to go away anytime soon. However, there's now a layer on top that is multiple trillions of dollars of opportunity, and that's why we're so excited about the new software industry. It's additive to the old software industry. And as I mentioned earlier, even the hardware industry has changed. What used to be $1 trillion data centers in the world, there's a brand new type of data center. And this new type of data center has a brand new function, and it's called AI factories. And so the traditional software data center has been augmented with this new TAM, and the traditional hardware industry has been augmented with this new incredible TAM called AI factories. Now, to realize the opportunities of AI, you all know this, and we need to continue to talk about it, is to make sure that we balance the opportunities with caution and dedication to public safety. AI is an autonomous system after all. It's an autonomous system. We are autonomous systems. An autopilot plane is an autonomous system. We are autonomous systems. AI is an autonomous system. A digital information autonomous system. And we have to think about its implications. The industry must design AI with the most advanced safety mindset. It's a lot more than just the application. The mindset of safety, the technologies of safety, the methodologies of safety, the guardrail systems, and the monitors and regulations of safety. Each industry needs to enhance its existing regulations to include AI products. If AI comes to the world in the form of a service, and that service is related to media and entertainment, the regulations of that industry should apply. If that is a product and it comes in the form of a self-driving car, that industry regulation should apply. Central to safety is the need to advance a broad range of safety technologies, such as data curation and truth grounding and alignment to values and guardrailing and cybersecurity. There'll likely be a whole new industry called cyber safety. Just as cybersecurity was really realized to be very important only 20 years ago, we realize now, long before the AI industry has started, that cyber AI, cyber safety AI, will be very important. Stress testing, or what people call red teaming, and much, much more. Government policies can foster innovation and open source collaboration while balancing regulation for public safety. And if done safely, generative AI will be enormously valuable to the world's largest industries. Now, AI is a computing breakthrough, and when you take a step back and think about The other revolutions and the other platform transitions we've enjoyed in the past 40 years since I've been in the industry, nothing compares to this. No description of the market opportunity, the market impact, is as significant as generative AI. Not the PC, not the internet, not mobile, not cloud. And so this is an extraordinary time. The demand for our AI supercomputers reflect that. No computer company, no chip company has ever experienced demand of this scale. As you know, NVIDIA is now the largest chip company the world's ever known. And yet, our demand is many times where our current levels are. And so that tells you about the extraordinary opportunities that are ahead. The world's largest internet and cloud service providers started the first wave, and you guys saw that. However, the next waves are now here, and we're starting to see the next waves build up very quickly. And at the core of that next wave are countries. Countries building sovereign AI infrastructures. And that's going to be followed by industries, companies and industries, building AI factories. Every company in the world today, largest companies in the world today, build factories of one kind. They might be building a car factory, a plane factory, furniture factory, factories, a drug discovery factory. And yet in the future, every company will have two factories. You have the factory for the car, and you have the factory for the software of the car, the intelligence of the car. You have maybe you're building a factory for lawnmowers. You have another factory that builds the software, the brains, the intelligence for those lawnmowers, because those lawnmowers are likely autonomous. Every single company building something today will have, building something with a factory, will have another factory. So the number of AI factories in the world will be extraordinary. Every company is about, in the final analysis, our intelligence. NVIDIA has 5 of the world's largest supercomputers running 24/7. We can't design our software, we can't design our chips, we can't do anything anymore without our AI. So we have 2 factories. We have a factory that we outsource to TSMC, and we have a factory that we run ourselves. Every company, every country will do the same. Nations have now realized their sovereign data embeds their people's knowledge and culture. Countries must train and own the AI of their society. Countries have awakened to the need for an AI strategy and are evaluating investments in AI research and industry, sovereign data and AI computing infrastructure, and safety policies. I'm delighted to see Singapore has updated its national AI strategy. It was announced several days ago by Deputy PM Huang. And I had the benefit of downloading, as I arrived, Singapore National AI Strategy 2.0. And if you haven't had a chance to read it, please do. It is a very well-written document. It is a very compelling strategy, very compelling vision, and very actionable strategies. Very, very sensible, well thought through, and embeds what I consider a great deal of wisdom and a great deal of aspiration for the future of Singapore. I'm delighted to see that. National Strategy 2.0 emphasizes several things that I really connect with. Number one is expanding the AI talent, building AI computing infrastructure. This new form of software, this new form of computer science, obviously is not something that we can do ourselves. That was software 1.0. Software engineers of my generation, when you first get to work, they offer you a terminal to a mainframe. And that terminal to a mainframe is really a glorified typewriter. And we spend our whole lives typing. But as you know today, all the typing in the world cannot create for you a generative AI. It is a theoretical impossibility for anyone to type that fast, to process that much data. And so today, in order for you to do engineering of any reasonable kind, you need an instrument. Just as I had a mainframe, you need an AI supercomputer. then lastly, promoting generative AI adoption across industries. And this is something that I read in that document and was really, really insightful, to recognize that AI is not a nice to have, that AI investing is not an opportunity, but it is a must-have, that it is a strategic imperative, capability to increase the competitiveness in the future of Singapore. The foundation of a national AI strategy starts with the foundation model. And we're delighted to have been working with Singapore on the Singapore Sea Lion large language model. It is one model for 11 languages, I understand. And it's a model that can only be created here, improved here, and obviously operated and refined here over time. We have excellent partnerships with DSO, DSTA, Singtel, NSCC, DBS. Everything in Singapore are acronyms. From now on, I'm just going to call her JP, Jacqueline Poe. Institutes of higher learning, universities, and research institutes, and many other government agencies and enterprises. I really value our partnership with all of you, and thank you for the partnership and the work that we're doing together. It's incredibly important to the future of Singapore. We're also working with local sovereign cloud service providers, and all of the researchers will be very happy to hear this, that we're working around the clock to stand up GPU clouds here in Singapore so that you could do your AI research, and building AI infrastructure and capacity to support the national AI strategy. Now, much more can be done in Singapore, and we're delighted to have partners across Singapore's vibrant technology ecosystem. Singapore aspires to be a global AI hub, and that starts by attracting the best AI talent and creating a vibrant ecosystem for researchers, developers, enterprises, and startups. NVIDIA is looking forward to working closely with Singapore government in areas including building AI computing infrastructure, a new AI center of excellence to attract world-class AI talent, and to expand NVIDIA's AI Startup Inception program to support and collaborate with Singapore's entrepreneurs, and to build the vital AI computing infrastructure to support significant GPU demand by researchers, startups, and industry. We're partnering with local sovereign cloud service providers with great urgency. So I want you to know that it is a very high priority for us, and we're working very hard and very urgently to get GPU infrastructure here. Singapore's national AI strategy states that 2023 is a landmark year for artificial intelligence. That is absolutely true. I think we'll reflect on history and realize that last year was fairly important, but this year was a fairly important year. You know, just as in any sport or any endeavor in life, every point is not equally important, and every year is not equally important. But this year is fairly important. And I think we'll reflect back and realize that as all of you pay attention to what is happening, why it's happening, and its implications in the future, you will be rewarded by your alertness and your insights. I was particularly inspired by how the strategy outlines a vision for Singapore to be a place where AI serves as a force for good, uplifts and empower her people and businesses around the world. We are honored to partner with the Singapore ecosystem, all of you, to realize this bold vision together. Thank you.
The future and how every country, every industry is marching along in this journey.
You might have even noticed, usually my tone and my energy level is much higher than today.
Is it the chocolate yao?
The reason for this is because I understand that Singapore is very understated. That this is a nation that punches well above your weight, but you're humble. 6 million people. The fact that you could be number one in anything at all on the planet is incredible. And yet, this is such a special country. And so whatever the secret recipe is of humbleness and low key, I thought that I would try to emulate that style today.
Thank you, Jensen. You know us pretty well. With that humility, perhaps let me kick off. My job today is to ensure a smooth dialogue with you and get insights. In the room today, we have different parts of the AI ecosystem present here. Researchers, developers, product builders, leaders from startups, big tech companies, large multinationals and big Singaporean companies, and many other
I am home.
partners. And you're welcome all the time.
This is where I want to be.
And you know, over the years, digital transformation in AI has not been a new journey for Singapore, and you've read our national AI strategy from cover to cover. That's really a version 2. Perhaps let me kick off with the first question, and then I have some questions that are already out there, which we'll go into. But you know, you look at various countries coming out with AI strategies. And in many cases, there are a lot of efforts and pillars of strategies within that. If you compare and contrast different countries, what do you think are going to be the 2 or 3 most important enablers for countries to succeed in their AI journeys?
In almost any endeavor, any journey, you have to take a step back and ask yourself, what is different about this circumstance? What is this about? 12 years ago, or more than 12 years ago now, when we started working on deep learning, 100% of the endeavors were around computer vision. Everybody was working on a new network for ImageNet, as history would very well have documented. And simultaneously, several researchers around the world reached out to us and asked us to help them because they realized that CUDA is essentially a GPU or a supercomputer that any normal person can have. Instead of having a supercomputer, you can have a gaming computer, and that gives you a supercomputer on your desk. And if they could just learn how to program CUDA in the way that is necessary for deep learning, it would really help them. And so we invented what nobody talks about, but it is the domain-specific language for all the computer scientists in the room, the DSL of deep learning. It's called cuDNN. Without cuDNN, none of the frameworks on the planet would have the access to tensor processing that it has today. And so we realized several things. Before we were enamored with it, I was enamored with it, but we took a step back and asked ourselves, what is the meaning for this? How is this going to change technology? How is this going to change computing? How will this change software? How does this change our company? We took a step back and we realized that deep learning at its limit was going to change everything. And so we started down that journey. And now let's take the chip, the system, the middleware, the algorithms, how NVIDIA develops software. Software today is, the way you develop software is profoundly different. The importance of data, the importance of a data strategy, different data strategies. And then we took it even to the next level and realized, what are the industries that we can affect? And this is the reason why we started in the industries that we worked on. Now, for nations, you have to do the same. You have to ask yourself, what is different? What is different about this? And what are the things what are the actions that we have to do? What are the strategies that we have to formulate? And the fact is your nation AI strategy captures a lot of it. The document is surely comprehensive. And now the next part of life is knowing what everything that you have to do is important, but you have to know what are the top 2 or 3 things to do. And the nations that are really making a difference are the ones that realize, number one, that the instrument is not only functionally necessary, but it's symbolically necessary. It is symbolically necessary. Now, why is symbolism important? Well, for what reason do you build capital structures or universities or all the same reasons that you need to have an environment where researchers can come to be inspired by the capabilities, to feel empowered by the capabilities, and to realize that they have the backing of an instrument that allows them to do their life's work. And so one of the most important things is, and of course, it might sound a little self-serving, but just realize that even if it is self-serving, I'm going to say it anyways, it is vitally important to have an iconic instrument that attracts the best researchers in the world, that unleashes your creativity, that you know whatever great idea you come up with, that your instrument is not going to be a limitation of your work. That creates a condition, a vibrant condition, for amazing researchers to want to come and attract other researchers.
No, thank you so much for that. I think it's a great jumping off point to first focus on the first pillar of our questions, which is really around research. And I would like to call upon Kim Pugh, who's the chairman of the National Supercomputing Cluster. He's been working very closely with your team and NVIDIA, but perhaps to get his perspectives on what he's doing, and also a question for you perhaps. Kim Pugh, please.
Oh, thanks, Gary. And morning, Dr. Jensen. I mean, it's amazing what has happened with the AI. And I was talking to Jackie, 6 months from now, 1 year from now, we're not sure what's going to happen. I mean, this morning we just saw the launch of the Gemini. It's amazing, right? But I'd like to move a bit away from the Gen AI, because I think everybody understands, and there'll be a lot of questions on Gen AI. I thought I'd like to move away from that. But before that, let me thank NVIDIA for the partnership with NSCC, where we co-invest in the GPU facilities. It's a relatively modest facility, but I hope it's the first step towards a 1,000 miles journey. So my questions that I'd like to pose, which I hope is in line with what Kieran would like to hear, relates to quantum computing. I understand that NVIDIA has a vision to be the leading quantum computing company without building a quantum computer. I'd like to, if you can share where you are in this journey, and then the challenges to make your GPU, APU, the de facto hardware to do quantum simulations, to develop quantum codes, test quantum codes, control quantum computer, or maybe integrate quantum computer with classical HPC systems. Thank you.
Yeah, I appreciate that question. And I really appreciate that you know what NVIDIA's strategy is to be the world's leading quantum computing company without building a quantum computer. And I know that doesn't sound sensible, but it is also very deeply our core values. And let me tell you what it is. We avoid doing anything at all, even if it leads to great prosperity, great profit, great notoriety. We avoid doing anything at all that other people can do. And the fact that there are so many quantum computers being built of all different types suggests that the world doesn't need us to do it. So the question is, how can we advance this industry? As you know, in order to build a quantum computer, the world's next computer, you need the world's most powerful computer to do that. And there are several things that we could do. First, in order to simulate the quantum algorithms, how do they know that the algorithms actually work? They need a quantum computer emulator. A quantum computer emulator better be a fast computer. And so NVIDIA's systems, as you probably know, is the world's leading emulator for quantum algorithm development. And there are some very important algorithms that needs to be developed. The post-quantum encryption, cryptography algorithms has to be developed now. And so there are a whole bunch of industries that we're working with, whether it's in digital biology, cryptography, weather simulation, crash simulation, a whole bunch of different simulations, optimization problems at large. And so there's a whole bunch of work that we're doing. The second is, even when the time arrives with a quantum computer is good at certain things, small data, big compute. Quantum computers are not good at big data, small compute. And there are many problems in the world that are big data, small compute. For example, inference. And so a relationship between quantum computer and classical computer, or accelerated computers, is necessary. We call it quantum classical architecture. And so we're helping the world develop that programming model. We call it CUDA quantum. And so we've developed a programming architecture and a system architecture. Third, the interaction between a quantum computer and classical computer, that interface is very complicated. Because obviously, one of them is very noise sensitive, and the interactions between it has to be extremely low latency. And so we've done a lot of work there in this classical quantum system architecture. And so we're working with just about everybody in the industry to do so. And if there's quantum computing work that needs to be done here in Singapore, we could really add a lot of value. We'd be delighted to do it.
Thanks for that. Next up, we have Russell, who had a question. He's over to Temasek. Russell, please go ahead.
Hi, Russell. Nice to see you.
Hey, hi Jensen, and welcome to Singapore.
Yes, thank
I
you.
have two things to thank you for. First, as a happy investor in NVIDIA, obviously thank you very much, stellar job.
Thank you, but I have to say I did tell you so.
I distinctly remember in the mid-60s, mid-2010s, you were coming to my previous company, Applied Materials, and I think the topic then was, why can't you guys help us make larger reticles? But that was a different era. But the second thing I want to thank you for is speaking at our conference last year in mid-November. That's about just 10 days before the launch of ChatGPT. And I think the fireside chat was amazing. Now, coming back to two things you mentioned this morning, I really like the concept of companies having two factories. One your product, one your AI factory, and much has been discussed in the digital realm per se. So I will come back to this point around the second factory, which I fully agree. To a large extent, I think this concept applies to countries too. So we as Singapore need to have our own AI factory, and I think the AI, our national strategy essentially calls for that. The second thing you brought up, Singapore is a small place, low-key, humble, 6 million people, punch above our weight. Now, coming to this era of AI, from your perspective, is it a possible scenario where we unlock our traditional constraints in terms of labor, in terms of talent, with the advent of AI factories? And like I think Gimpyu said earlier this morning, Gemini was just announced, and I think in that fireside chat we had 12 months ago, we talked quite a bit about Omniverse, the digital twin, the high fidelity that replicates the synthetic world, the physical world. If you combine these two, and I think you've shared some of these before, high fidelity digital twin plus large multimodal models, and I think you guys just announced you with that. Can this combination help us unlock some of Singapore's constraints? That was my question.
Yeah, Russell, thank you. First of all, great to see you. First of all, you know that today's large language models, at the core itself, is not sufficient. It's surrounded by a whole bunch of other AI models. And one of the AI models is a reinforcement learning human feedback model. It's called alignment. You just raised an intelligent child, and it knows everything, but it doesn't know what's right or wrong. And by it experimenting, we give this child feedback. We align this child to our core values of right and wrong, and that's called alignment. Well, how do you do reinforcement learning for a robotic system? That can do anything, but it has to operate safely in an environment that was created for humans. And so we have to provide the right and wrong signals to this physical robot. And the way to do that is reinforcement learning, physical feedback. And that physical feedback can only really be done in a physical simulation because the AI needs to learn really fast. And that's what Omniverse was designed to do. To be the next generation of AI, where it's physically grounded. It understands the laws of physics, it understands the constraint of the physical world that was created for humans by humans. And let's see, the other question that you asked, really important. Remember, at the core of AI is the automation of skills. I would argue that Singapore has an imperative to dive headlong into creating your language model, your sea lion, which today is at a good place, but it needs to be at a great place. And the reason for that is because if you don't build sea lion, who's going to do it for you? The work of building sea lion, that is 11 languages, understands the culture, the Asian culture, understand this region's culture. Who's going to go do it for 6 million people? The market's too small. And yet it's vital to your industry. This is a perfect example of something that you must do for yourself because nobody else will come and do it for you. Number one, you have the technology, you have the partners, you have the rich ecosystem, you have the will to go do it. Two, you, quite frankly, not only need to do it, you will benefit by doing it. Nobody can take this digital intelligence market from you. And the reason for that is because you possess the data, you possess the will. If you build it, the foundation model of Singapore belongs to Singapore. It will never be outsourced and then imported. Outsource Singapore's data, import your intelligence, make no sense. You should manufacture it right here. And then that foundation model will be the foundation by which all of the technology industries, the researchers, can all build upon. And so that research will lead to AIs, and what does AI do? AI automates. You will have not 6 million people, you will have 60 billion workforce. They just happen to be digital workforce. This is just an extraordinary time and extraordinary opportunity for you. That's why I'm so excited to be here to celebrate it with you. And so,
Thank you. Now it's time to open up to the entire audience. I'm sure many of you have questions on your mind, so please raise your hands, the mics will come to you. A quick short introduction about yourself and a quick question. Thank you. Gentleman over there with the black shirt.
Jensen, thanks for coming by and thanks for the dialogue. My name is Charles. I'm the CEO and co-founder of Bifrost AI. We're building a platform for generating 3D content at scale. I have a pretty simple question. I was just wondering, given the current AI landscape with the key players in the industry, like of course yourself, NVIDIA and all that, if you were, say, in our position again, you were in your 20s, you're a young co-founder of a new startup, unjaded by the realities of running a multi-trillion-dollar MNC, what would you be working on? Just because there's so many portions of the stack, there's the hardware layer, the infrastructure, the software, applications, where would you be focusing your attentions on?
That's a really good question. And as you know, when you said just now, where the stack, right now as we speak, that stack is being completely revolutionized. That stack has kicked up one level. Remember, only 10 years ago, the big phrase of the computer industry, what everybody was talking about was PaaS this, PaaS that. Remember that? Platform as a service this, platform as a service that. Because 10 years prior to that, it was IaaS this and IaaS that. Isn't that right? Okay? And of course, engineers are not very good at coming up with names, and this is one of them. But you know that the world doesn't need PaaS anymore. The world doesn't even want to think about IaaS. We want to think about functions as a service. And we want to create functions and applications by connecting these intelligent functions together. And the interaction with these functions are prompts. And these prompts could be quite vague or quite specific. But it will be very effective no matter what you do. And we could connect a whole bunch of these functions as a service up in the cloud into applications. And so that's That's where we are now as an industry. Now the question is, in your case, where do you fit? Well, just remember very simply this. If you are clever enough to come up with a strategy where you are the gorilla on day one, you have an opportunity to succeed. Now, I just gave you a very short version of what almost every business book will teach you. How to find niches. The reason why you find a niche is so that you are a significant player in a small market. And the smaller you are, the smaller the niche. To the point where if it's only just 3 people in a family, you own a grocery store in a corner of a neighborhood. Very, very specific niche. And so the question is, what is your niche? You have to go find that niche. And I know it's not an easy question to answer, but remember, we survived, NVIDIA survived for 30 years with nobody caring about us. And the reason for that was because NVIDIA's niche was a $0 billion niche. If you're serving a $0 billion market, I promise you, you will have no competition. And that buys you a lot of time.
Gentleman over there, next question.
Hi, Jensen. My name is Damon. I'm from the Bay. I never got to meet you, but I'm a 4-time founder in the Valley. So I'm out here in Southeast Asia. My family is Southeast Asian, which is awesome. But I'm very excited to meet you. How do you see Southeast Asia becoming more and more important now with the sort of decoupling between the United States and maybe China and maybe this whole thing? I think that the potential for growth, which I'm telling all my friends in San Francisco, that if you're looking for growth, Southeast Asia is where it's going to be at. And I just think this place is, it's magical. I do love Singapore. It's actually really awesome. But how do you see that sort of playing out in the next 10 years?
First of all, home run. It's an utter home run. The conditions that you described, wherever they came from, whoever is right, we don't have to weigh into that, but whatever those dynamics are, has caused Southeast Asia to be the home of many exciting future startups. And the reason for that is because you can freely build a company with access to resources that you can then serve the world. And the ability, that condition that I just described, access to resources, talent, infrastructure, so on and so forth, it's an essential condition for startups. And Southeast Asia is in a perfect place and a perfect time. Now it's up to the ecosystem, and this is one of the areas that we care very much about, is to make sure that the startups have the resources and the collaboration and the partnership and the support necessary for them to become not a startup, to become a successful company. And as you know, for large companies, even though they don't say so, but very, very, very much so for a startup, the definition of a startup is a company that's always going out of business. And so you better hurry. You better hurry to get some escape velocity. And so time is, as you know, not in the favor of startups. And so there are a lot of startups here. I don't mean to scare you any more than but you should be scared plenty. I'm 30 years into my startup, and I woke up scared this morning. so I don't think that will ever leave. But you guys you're in a great place, great time, great place.
Gentleman over there.
Thank you.
Hi Jensen, good morning. Alpesh Patel, I'm Vice President at Hyundai Motor Group's Innovation Center in Singapore. So we're Hyundai Motor Group's most advanced factory in the world. Our goal is to manufacture personalized mobility solutions in an autonomous and automated way. And the question I have for you really relates to what you've mentioned earlier. So you envision 2 factories, one to build cars, one to build the intelligence around cars. The question is, what about the third factory? And that factory would be about building the intelligence that's needed to manufacture the cars in an automated and autonomous way. And how do you see the convergence of digital twins, Gen AI, and other technologies to realize that vision, not only in the factory planning side, but really when it is about running the operations in real time and make that factory completely live? Because what we're looking at is personalization.
Yeah, frankly, in your question, you demonstrated you actually know the answer, and I think you're spot on. Every instrument will have a digital twin in the future, and the building is an instrument. A factory is an instrument. A factory is a robot that will orchestrate other robots to build objects that when it leaves the factory will be robotic. Isn't that right? So robots building robots, that will be robotic. And each one of these robots has a digital twin. And the digital twin will exist before the physical version. And once the physical version exists, the two will operate concurrently so that we know the two are aligned. And the reason why we need to know that the two twins are aligned is because later, all the software development we do, the replanning we do, the reconfiguration we do, all of the optimizations that we do, we're going to subject it to the digital version first before we put it into the physical version. Isn't that right? We're going to save time, we're going to save money, we're going to be able to do things unimaginable in the past when you had to prototype it physically. If you only prototype things digitally, you're willing to do superhuman things. Like, for example, we design our chips completely digitally. The physical version of the chip is a kind of a foregone conclusion, if you will. I know it's going to work. And the reason why we are so brave in designing digital chips is because we do it digitally. We've designed millions of versions of our chip before we build it. And so we have a lot of confidence. You will have a lot of confidence in building factories of the future. Reducing energy, reducing cycle time, reducing cost. You'll push it to the limit. It'll be great for the environment. It'll be great for your business. Quite frankly, it'll just be fun anyways. And so I think the digital twins will revolutionize everything in manufacturing.
Thank you. Maybe on this block over here, the lady over there.
Talking to you guys is making the enthusiasm come back. I'm becoming less and less Singaporean.
Hello, Mr. Huang. It's my pleasure. So I come from a midline China-based fund. Actually, we launched this fund quite early. We focused on this AI industry for several years and the supply chain. So it's a little bit sensitive about this question since you forbidden to sell like A100 and H100, this advanced chip to China. So we do a lot of research that Chinese have a revolution in this industry. Like they try to develop the new version of like DRAM and ReRAM structure, try to like the computing and storage integrated chip to maybe use as the GPU in the future. Do you think, and it's cost down and more effective, so do you think it's a challenge for GPU in the potential market in the future? Thank you.
That is, the answer is yes. I think that irrespective of regulation, Chinese companies, technology companies, have a lot of opportunity. And look, China went from a very small automotive industry to now the world's largest exporter of automobiles. It builds the most advanced cars. BYD, NIO, XPeng, Li Auto, they're all partners of mine. They are amazing companies. The rate at which they went from absolutely nothing to building world-class cars. And today's automobiles are very complicated, completely software defined. It's basically a computer with 4 wheels. This is very complicated stuff, and yet they do it with so much speed and so much excellence. And you could just apply this to just about every industry. And so I have every confidence that China will be world-class at building computing technology. Our circumstance is very straightforward. NVIDIA builds very critical technology, as you know. That artificial intelligence, the ability to produce intelligence, is obviously critical. And obviously critical to every country, to every company. The United States would like to regulate our technology so that the most advanced versions of our technology are not available to China. That's not a decision I get to participate in, but we have to respect it. And so the first thing that we have to do is design products that precisely, very, very precisely follows the regulation. We did it the first time when the regulation came out a year ago. We're in the process of regulation that just come out again. So we're in the process of coming up with new product lines that are very clearly, specifically in compliance with the regulation. We'll make those products available to our Chinese partners. They're anxious for us to hurry to get this work done. We're working as fast as we can, and I hope that we'll be able to serve the Chinese market as soon as possible.
Gentleman over there.
Hi, thank you. We are building autonomous delivery robot that deliver food and groceries to your house.
Yeah.
So basically, we are a small startup.
Good idea.
Yeah.
The food is not so impatient.
So the problem we have is that there used to be a chip shortage in the past, and as you mentioned, that the demands that when exceed the supplies. And as a small startup, nobody wants to promise us anything because we're too small. But what if in a few years, we get so big that we need a lot of chips? Is there any advice you have for us? And does NVIDIA has any program for the startup? Thank you.
First of all, sorry. As you know, a startup time is not in your favor. And when you can't access, this is no different than when I was starting up NVIDIA, and I just raised money, I have money, but I don't have a computer to design my chip. I would be utterly desperate. I would be utterly desperate, because every single day, a day goes by. And startups don't have that many days. And so I completely understand this. If you need GPU infrastructure, reach out to our guys. We have a program called Inception that is designed to help smaller companies, so that someday you become a giant company. And just, my only request is when you become a giant company someday, just don't forget us little people and help me some, okay? But that's the answer. Let us do everything we can to be helpful to you, and then grow as fast as you can. Okay? And we'll get through the GPU shortage.
Thank you. Gentleman over there in the picture.
My name's Logan Basprin, and I'm a cardiologist, and I head Southeast Asia's only AI cardiac imaging research lab. A quick PSA to everyone, please look after your heart health. My question, you mentioned GPU and compute, it's a very valuable resource. Nations are competing for it, but industries too. My question addresses, I guess, both of them to you. One is, where does healthcare rank amongst the different industries? And number two is, how can Singapore as a nation serve the region, more specifically AI-based healthcare?
Yeah, first of all, I appreciate that question very much. Healthcare, there are only two industrial initiatives in our company. One of them, aside from accelerated computing overall, one of them is autonomous vehicles, transportation. And we work with just about every company in the world, either in the data center, building data twins, building computers for the car, or the algorithms for self-driving. In some way, we're collaborating with just about every car company. We have another program called Clara, and it's our healthcare practice. You probably know this, but from gene sequencing, software-defined gene sequencing, to medical imaging, to cryo-electron microscopy, to virtual screening, molecular dynamics simulations, quantum simulations of molecular dynamics. all the way to applying large language models, foundation models, for different aspects of drug discovery and virtual screening. We are central to all of that. We have a really important platform called BioNemo, and I urge you to look at it. It's basically a foundation model for digital biology. Digital biology, of course, is a complicated, different omics of digital biology, the different domains of biology. Each one of them will likely have different foundation models for a long time. And we have a large team inside the company collaborating with researchers. And we put these large language models, these foundation models for digital biology, as functions, as APIs in the cloud. And so you could send us a prompt, and it gives you back proteins or chemicals, or or conformations, or so on and so forth. And so this is an area of great importance to us. Most of our company's investments in small companies are in the field of digital biology. If you were to ask me, what is the next gigantic, crazy, exciting industry, I would tell you is biology. Because for the very first time, we could use computers to understand this incredible complexity called living things. And if we can understand all these different languages, surely we will find a way to understand proteins and chemicals and organs and the different omics of humans. And so I think that just as engineering, computer-aided design revolutionized computer design, computer-aided drug discovery will revolutionize the drug discovery industry. I'm certain.
Thank you. The gentleman over there. Thank you.
Hi, it's Daniel. Hi, it's Daniel from Jam. We're an open source alternative to ChatGPT that runs on laptops or servers 100% offline. So actually 2 questions. They are about computer architecture. Where do you see computer architecture going in the next 30 years? And are the lines between memory and compute going to blur?
I'm going to work backwards because I know that answer best. The line between computing and memory will persist forever. And the reason for that is because we have working memory, short-term memory, long-term memory, persistent memory. That hierarchy of data will never change. And sometimes it's real-time data, streaming data. Sometimes it's a small working set, otherwise we call context. Is that right? And so we have, and then we have collaboration data. So the world has all these different hierarchies of data, and the temporal nature of the data is so diverse. Why would it be possible to come up with one memory architecture to serve all of that? It's not even sensible. And so I think that the interface between memory and processing will persist forever. And the speed at which you want to access the memory, of course, has a lot to do with efficiency, and so that's going to persist forever. It is a fun part of computer architecture. It is the core part of architecture for computer science, since the very beginning of my career. And my guess is that in 30 years' time, when I'm still working, hopefully, that it will persist to be a great challenge. Second, how do I see computer architecture? Every single generation, every 10 years, the abstraction of a computer clicks up one notch. It takes about 10 years. The reason why 10 years is it's kind of sensible. It's kind of 3 human cycles. And it takes us three tries to get something right. And maybe it takes two tries to get something functional. The first try is just nonsense. The second try is functional. And the third try gets adopted. And so that's about a 10-year cycle. We're now to a point where the actual processor itself, the actual hardware itself, may not matter as much. So the idea that a large language model is essentially the CPU of the next computer. It's a strange thing because the large language model is now the central processing unit, and the large language model runs on a processor that is not the CPU, right? And so the large language model is now the central processing unit, but it runs on a GPU. And so I think for a lot of humans that's going to be a great teaser, but that's essentially it. that this large language model will now be surrounded by a whole bunch of other language models. Just as a computer is surrounded by a whole bunch of peripherals, you're going to have the future computer will be a kind of a general purpose large language model, and it'll be surrounded by a whole bunch of specialists. And these specialists will be connected through working memory, context memory, storage, and the way you'll cobble them, the way you'll connect it together is not like SDKs in the past, but you'll assemble them like teams. And you'll create an AI that has all these different team members. It'll aggregate around a large language model. You might call it a RAG, retrieval augmented generative model. And you chain them together, and so on and so forth, all the things that you know. And so I think computer architecture is now chained officially.
Gentleman over there.
Hey Jensen, I'm Donald. I run the group data office at OCBC Bank. We're a big fan of NVIDIA. We have about 200 of your GPUs running our on-premise LLM inference. My question was, everyone in the room, all the organizations are experimenting with generative AI. Everyone's doing a lot of POCs. There's not a lot of organizations sharing production-grade success. Why do you think organizations are struggling to do this at scale?
Yeah, I really appreciate you saying that. The thing that's really quite remarkable is that until LangChain came along and RAGs came along, quite frankly, it's not that easy to do POCs. And if you go back and reflect on when did LangChain really burst out into the environment, where did all these vector databases show up? And as you know, there are a whole bunch of different ways to build vector databases. How do you create these semantic search engines? How do you re-rank the data? How do you chunk it up? There are a whole bunch of wisdom that has to go and know how that goes into it. But the amazing part of it is everybody's doing it. Number one, everybody's building RAGs. Number two, we've only been doing it for about 4 months. And so the level of the pace of the world in adopting this new computing capability is extraordinary. Remember, it was 3 years before anybody gave a nevermind about the first iPhone. The rate at which we're all doing this is extraordinary. And now my assessment is because the latest generation computing architecture, large language models, has democratized. In fact, we've lowered the bar of creating amazing applications for the first time. That's why everybody's doing POCs. And so I have every expectation that in 6 months' time, every company who wants to try to do it will do it quite successfully. And building your own chatbots is a matter of, I don't know, an afternoon. And if you're not sure about it, just look on YouTube because kids are doing it.
There's not a democratization. Gentleman over there, in the green shirt.
I was told that in Singapore, people are shy about asking questions.
Hi, Jason. My name is Jensen Huang. I'm a new assistant professor in computer science department at National University of Singapore.
Oh, that's
I
great.
just obtained my PhD from UC Berkeley. So, and I work on AI safety, cybersecurity, and crypto. So my question is, suppose you were in your 20s in the current world. What you will do, like as a new graduate, whatever, master or undergraduate or fresh PhD in UCS, what would you do? Will you like join NVIDIA as a new employee, or you want to do something different? And the related question is, back to your 20s, you were back to like 30 years ago. What were you thinking at that time? And what were you thinking at that time?
Sure, I appreciate that. Remember, the first question that I was asked was about where to focus. At the time, in 1992, the entire industry was focused on one single idea, the microprocessor. That was the revolution at that time. The microprocessor, the CPU, the single chip central processing unit. and the awareness of this law called Moore's Law. I just described 1992 to you. And it's the beginning of this idea that maybe a computer could be personal. Windows was about to come out. This is Windows 3.1, Windows 2 at the time, Windows 3.0, Windows 3.1. Don't forget that the major breakthrough of Windows wasn't until Windows 95. I'm talking about 92. And so 3 years prior. Our belief was that even though this general purpose processor could do a lot of things, and the CPU revolution was just getting off, we believe that we could add value and create a different type of computing that is at the fringe of. That there are applications that will not be possible or not cheap enough, not cost effective, if you were to do it in the general purpose way. But if you were to create a specialized processor that is very good at certain types of algorithms, in the case of computer graphics, for example, which is not different than linear algebra, which, as you know, is kind of at the core of deep learning. That type of algorithms could benefit from a specialized processor. And by doing so, we could either reduce the cost of doing computing by a factor of 100, or we can improve the performance by a factor of 100. Either way, we could enable a new class of applications. That was it. I just described NVIDIA in 1993. I just described NVIDIA in 2023. It's exactly the same company that I described. What would I do today? I think that the value of most intelligence is in crossing of domains. Specialized domains is terrific. We need people who are highly specialized. But if you're highly specialized across several domains, then you can see the bigger picture. The reason why NVIDIA is successful today has a lot to do with the fact that we could see the application, the algorithm, the system, and the chip at the same time. We are quite rare in that way. Most companies are either chip companies, or most companies are systems companies, or most companies are algorithm companies. We're quite rare in the sense that we're specialized in a domain and we slice across all of it. Some people call it co-design. We call it full stack. Some people back in the old days, we go understand the algorithm, however you want to describe it. I think that crossing domains is always valuable. You will always be unique. And if somebody would like to work for a really fantastic company, I might throw in NVIDIA as an option.
We have time for last two questions, but let's go ahead.
Hi, Jensen. Nice to meet you in person. My name is Wei Lu. I'm currently an associate professor from SUTD, Singapore University of Technology and Design. So first of all, I want to thank a big thank you to NVIDIA, because I really received a lot of support from colleagues in NVIDIA here in Singapore. Specifically last year, we actually submitted a proposal to build a national center on natural language processing, focusing on building regional languages. I'm really glad that NVIDIA, just heard from you, NVIDIA is going to help us with such a model. Back then, we really received a lot of support in that proposal. But maybe because we submitted the proposal too early, that was before ChatGPT. So, my question...
That is, in fact, too early.
So my question is, I'm coming from academia. So as we all know, the research progress in language model is largely driven by industry. So do you believe breakthroughs can also originate from research labs in academia? And also, do you have any advice for researchers in academia who are passionate about contributing significantly to the research of language models and generative AI?
By the way, you asked a monumentally important question for the future of higher ed. This is the same, what I'm about to tell you is the same thing I told the president of MIT, Harvard, Stanford, Berkeley, some of the world's greatest schools. If they don't solve this problem, the world's large AI companies like NVIDIA, Google, Microsoft, we are more than delighted to welcome the world's AI researchers to our company. But obviously, that's not going to lead to a better society. We need innovation in open science. We need open education discovery, open knowledge discovery. We need open source. We need open publication. NVIDIA publishes today for that reason. We need to contribute to knowledge so that other people can build on the shoulders of that. However, today's universities simply don't have the instrument to do the research. Full stop. How can you attract world-class researchers to any university if you don't even give them a calculator for their work? It's essentially the same as come to our university. We'll give you a desk and some paper. Well, thanks for the offer. What are you going to do with that? And so you need to go somewhere where there's an instrument. That's why people come to us. NVIDIA has seven professors. We're going to get several more. The number of professors, visiting professors in our company is growing faster than the size of the company. But the reason for that is because increasingly it's just not possible to do research. And we're delighted to host the visiting researchers and teams of interns, and we do groundbreaking work. And I'm not alone. Remember, I just described what Google does and what Microsoft does, and so on and so forth. And so you've described a core problem. The only way to solve that is to solve that at the university level. It is not a big deal. It's a $100 million problem. It's a $100 million problem. Now, surprisingly, I said $100 million problem, and it's not a big deal. It isn't. How big is a football stadium? It's measured in billions. With a $100 million investment, you enable every single school in that university, all the way to forestry and oceanography and social sciences, to computer science, to sciences, to engineering. And so the investment level is not significant. Now, it is so insignificant that I funded one for my university. And my colleague, my co-founder, Chris Malachowski, just bought one. It's not that much money when even humans can buy it. And so I think that you've identified a very severe issue, and it requires a transformation of state of mind and recognizing that no meaningful science can happen anymore without an instrument. It costs way less than the building.
Perhaps the last question of the day.
Oh, the last question, you guys. The pressure is so high. Please ask a happy question.
So I will have the last.
Oh my goodness. First of all, this is a self-reflection. You have to ask yourself, am I the type of person who can ask a happy question?
I want to be happy after the answer.
Okay, all right. I'm a type of person who can answer it no matter what in a happy way. All right, I can do this.
Yeah, so my question relates to the other questions. It's basically via links. We are doing a bunch of graph AI to LLM. So it means that, let's say, a graph neural network lists candidates for an LLM to do, for example, math without improving. And NVIDIA has its own reprover, which is a RAG. And then it's perfect for Singapore because there's a leaderboard and everyone is like competing on Math Olympiad questions. But it has a lot of applications in biology because if you solve this, then of course it will be quite amazing.
As you know, reasoning is an optimization problem, and an optimization problem can be reflected, can be expressed in a graph.
Exactly. And then it's very good because for the first 10 years it was a very niche problem with a 0 billion opportunity, so we're on the right way. And then I think the second part of my question is like, when you see the future of it, I think right now in math up to 3 lines you can do things, but then for the 4th and the 5th it's becoming very difficult. As you said, multi-step reasoning is super hard. But as you see what breakthroughs you are seeing, like what do you see, what will be these peripheral applications next to LLM that will enable it to do? And the other is that when you help small companies or to do these things, which is not just 1, 2 GPUs, like how can you enable startups to access some of those supercomputers that you need for these search policies to try so many things so that in the end you solve the problem?
Yeah, you're describing a really, really interesting area of research, and you're also describing an area of research that's going to require a lot of computation. And the reason for that is because where we are with AI today is fast thinking. Isn't that right? Within milliseconds, it's returning my prompt. Okay? And so it's generating a response to me. It's fast thinking. It's barely, well, it's not thinking. And so it's fast generation. What you're describing is reasoning. This is slow thinking. System 2, right? System 2. And so you contemplate. You sit back and you reason about it. You kind of shake back and forth like this. That's kind of how I do it. I don't know why I do this. I think I'm shaking up the neural network a little bit. And you're going, okay, if I go down this path, then I'm going to confront with these other options. If I go down that one, I'm trying to figure out what my cost function is. Isn't that right? And sometimes I'm not sure, and so I try an experiment. I do reinforcement learning. I try an experiment. I prune off some part of my graph, right? Eliminate the parts that are obviously wrong. I can now torture myself through another part of my graph. And so you're going through this, and sometimes it takes a lifetime, like what I'm doing, okay? But this is long-term thinking. While you're doing that in a computer, obviously the supercomputer's off going down these paths. And so this no longer is an inference that takes a second, but this is an inference that's going to take, well, it's going to process for about a day, or a month, or a week, and it comes back with a plan. This is the most optimal plan. And so there'll be a whole lot of optimizations, as you know, to prune and to eliminate the various cost functions and the different path chains. And so I think you're describing the next breakthrough, reasoning and optimization. And by doing that, we're going to expose a ton of opportunities. How would you do this as a startup? It's not easy. I got to tell you, you've selected a startup problem that requires a lot of funding. But the other part to realize is that money, as it turns out, is not that hard to get these days. What you described is a very meaningful problem. It is trying to be solved in many areas, so you better find your niche. Optimization problems have niches. You better find your niche, and then get some partners. We'll be delighted to see if we can be helpful, get funded, and but what you described, I think, if you find the right application, has a real opportunity to make a great breakthrough, really meaningful work. I want to thank all of you for the great questions.
Thank you very much.